We present here the Biotron device, which has been designed to explain how physicists characterize infinitely small objects like nuclei or particles. By transposing the process to macroscopic, gravitationally interacting objects. The pioneer experiments were performed by Rutherford in 1911, and since then the technique is the same: throw particles against others and describe how they interfere. The first stage of such an experiment is to obtain accelerated objects. We use here marbles as probes. We accelerate thanks to a slope. After that, the marble interact with a changeable potential representing the object to probe. If we use here such a bump as potential, analog to the Rutherford experiment, we can observe that the launched marble will deviate, depending on the distance to the potential called the impact parameter. In a head-to-head collision, the marble can come back to us, whereas if launched far from the potential, it will have a straight trajectory before being detected. One of two marbles are not enough to conclude, so we repeat the experiment with tens of them. Note that the marble colors depend on the impact parameter. The resulting distribution is a priori characteristic of the potential, but in order to properly interpret it, we need theoretical calculations. We see here that the experimental distribution shows a depletion in the center, as predicted. We can repeat the experiment by using a well as potential. We see that marbles are deviated here on the other side, and we can repeat the experiment with more statistics. Here, the result and the simulation, we see a bump distribution contrary to the previous potential.